Okay, dear students, thank you very much and assalamu alaikum on the channel Biopharmaceutics Mentor. Today we have an experimental proof to clear our concept about the clearance. There are so many questions. What are the factors affecting on the clearance? And the very common question is either concentration of the drug in an organ or the system is have any type of the influence of the clearance. So for the answer of this question, we have made this type of the setup. This setup is already explained in the Sunil Jambekar. We have already made an experimental exercise in our exercise book. And now we are going to clear our concept regarding the concentration dependency of the clearance. For the sake of understanding, we tried to make the clearance concept. Now we'll start officially with the. Now we are discussing with the clearance, and is there any type of the concentration effect? This is our question, and our answer is yes. We can prove it by making tank and faucet analogy experiment. In this experiment, we will assume that this part is the organ and this is the blood flow which is coming toward the organ, and now this concentration is the concentration of drug, blood or plasma which is coming out from the organ. Now we have adjusted the system. In this system, we are adding 1 drop per second in the system having the drug concentration which I have shown in the form of the color, and 1 drop is getting exit from the system. So according to our clearance definition, clearance is actually the volume which is getting cleared from the drug at unit time irreversibly. Now this amount of the concentration which is coming out from this organ is, we are assumed that this concentration is the amount of drug which we are collecting in the urine. Now our question was either that clearance concept is dependent on the concentration. First of all, we will observe 2 or 3 different things. For example, with the passage of time, we will observe that the color of the medium inside the flask or the organ, we can say, should be changed. Why it's changed? Because it is getting to be dilute. And the other is the amount of drug which is passing from that system is also depend on the concentration. At the start, concentration of the drug is higher, and we can assume that maximum concentration is getting out from the organ. And with the passage of time, we can say the concentration of the drug, which is now decreased in the system after a few time, then the rate would also be decreased. So where we have the same, we can also make another setup of just like this, and observing that its initial setup and then after 1 hour. When we see the same system after 1 hour, we will observe that the color of the medium would be fade, and then we can assume that the concentration of drug will also be changed. So for this, when we calculate, for example, we are adding 1 drop per second, and we are assuming that 0.05 ml per second is the volume, is the basically clearance of the drug which we are getting. So we will assume that it's our initial stage, and we can also write after 1 hour. After 1 hour, clearance would be the same because 0.05 ml per second. Because we are adding same amount of the drug, same amount of the medium inside the system, and same amount we are getting exit from the system. So we are adding 1 drop per second and getting 1 drop per second. 0.05 ml per second, 0.05 per second. We can say that clearance would be 0.05 ml per second at that time, and clearance would be 0.05 ml per second at that time. But when we calculate the exact value of K, rate constant, then our K would be equal to, we will assume that total number of volume. For example, we are assuming that it's we can say 1 liter of the volume, and we are adding 0.05 ml per second. So we will divide 0.05 ml per second with 1000 ml. And our rate would be equal to, we will say 0.000 tetra 04 per second, because ml will be cancelled and we will get the result in per second. So K at the stage of the before initial stage would be 0.tetra 05 per second. Once again, here we have same volume, 1 liter, and adding 0.05 ml per second inside the system. And our K in the same case would be, K is 0.05 ml per second, which is clearance, divided by total volume. And we will get 0.tetra 04 per second. In these stages, we are at the same area. For example, we are at the same position of, after when we get the same concentration, same clearance before at the initial stage, and after 1 hour we have the same values. But where we are different on the rate of change of amount of drug. For example, with the passage of time, when we calculate dxu over dt, which is equal to our clearance, and multiply with the plasma concentration. According to our second definition, which we have already mentioned in our previous video, it's a basically ratio between the rate of change of amount of drug with respect to time and the concentration of drug which is present in plasma. Okay, we can write CP1 here, because we are collecting the concentration at the stage 1. And in the same case, we have the same formula, rate of change of amount of drug with respect to time, which is equal to clearance into CP2. Okay, dear student, here is the basic concept. Here is the answer of our question. Is there any type of the concentration present inside the organ or inside the system is affecting with the clearance? Say when we want to calculate the rate of from this. Now our first concentration CP1 is greater because we have the maximum concentration. And with the passage of time, CP2 is the lesser concentration. And at the stage, after 1 hour, we have the less concentration. When we multiply this CP1 with the clearance, we will get another answer. So we can say at the first stage, we have the same values of the clearance. Both are the same. We have the same rate constant value. Both are the same. But in case of rate, we have got not same results. Why we have not have the same results? Because we have the different concentration. So concentration of the drug inside the organ is directly influencing. As we have the lesser concentration, then our rate would also be decreased. And say vice versa we are. For example, here we want to calculate clearance of the at one time. We will divide this rate with the CP1. Because CP1 is higher, so we will get the higher concentration, higher clearance value. And with the passage of time, after an hour, when we divide this factor with the CP2, because here we are dividing with the CP1, our answer is different with the dividing with the CP2. So conclusion is rate of drug concentration with the as we are getting the excrete is depending on the concentration of the drug. Thank you very much. It's a very basic concept. I hope you understand all this, and how to calculate the clearance from this we will share in the next videos. Thank you very much.